So we're now looking at an example of using related rates to solve this. In this example, we're assuming that y and x are functions of t, and we're also assuming, or we're looking for dy dt. So we want to find dy dt. I'm just going to read the directions that are in the book just so that you hear what they say. So assume x and y are functions of t. Well, I guess I just said that. And evaluate dy dt for each of the following. And so this first one, 8y cubed plus x squared equals 1. So everything's already defined for us. We're just going to go through and we're going to differentiate both sides of the equation. And remember how we would denote that? So we're looking at d dt. This is before we took the derivative of the left-hand side. 8y cubed plus x squared is equal to d dt, so the derivative with respect to t of 1. So when we take the derivative of 8y cubed, that's going to give us back 24y squared dy dt. Plus, taking the derivative of x squared, we get 2x, but this is dx dt. Excuse me, is equal to, and the derivative of a constant is 0. So we want to find dy dt. We can either isolate that now, or we can start putting in our variables, what we know, values. So let's just solve for it now. So if we solve for it now, we would isolate the term with that piece, or any of the pieces that have dy dt in it, but there's only one. So we have 24y squared dy dt. Get the other piece on the other side is equal to negative 2x dx dt. We can divide both sides of the equation by this 24y squared, and we get dy dt is equal to negative 2x dx dt all over 24y squared. So I notice there's a little bit that simplifies. 2 and 24 both have 2 in common. So we can say, well, 2 goes into itself once. So we're left with a negative x dx dt, and 2 goes into 24 12 times. So let's go back up here and plug in what we know. So we have dy dt is equal to, we have a negative x. Well, x in our case is equal to 3. So negative 3 all times this dx dt. Well, dx dt we're given is 2 divided by our 12 times y squared, but y we're given is negative 1. So negative 1 squared. So let's just simplify that down. So we have negative 3 times 2 is negative 6, all over 12 times negative 1 squared, which is positive 1, is 12. So we find the rate of change of y with respect to t is equal to negative 1/2. So here's an example of a related rates problem. And so we'll have more examples, and they are not always this simple. You might have to use your product rule or your quotient rule. So just be aware of that. Looking at another example, we have x squared plus y. That's all divided by the quantity x minus y. And this is equal to 9. We're given dx dt is 2, x of t, which it just says x, but it's a function of t, is 4. and y of t is 2, and we want to find dy dt. So we want to take the derivative of both sides. I notice when we take the derivative on the left-hand side, we need to use that quotient rule. And so we need to take the derivative of the top. And so the derivative of the top, derivative of x squared is 2x dx dt, plus the derivative of y. So the derivative of y is 1, but dy dt. That's all times our denominator, which is parentheses x minus y, minus this whole numerator, so x squared plus y, times the derivative of the denominator. So the derivative of x is 1, and then that's a dx dt, minus the derivative of y, which is 1, dy dt. And this is all over your denominator quantity squared. So x minus y quantity squared is equal to the derivative of 9, which is 0. Okay, so this might be the case where it would be easier for us to plug in what we know now instead of just solving for dy dt. So if we do that, we have 2 times x, x be in red. So 2 times 4 dx dt. So dx dt in here is 2, plus 1 times dy dt. Well, that's what we're looking for. So plus dy dt. And this is all times x minus y. So 4 minus 2. Minus x squared plus y, and x is 4. So 4 squared minus 2, all times 1 times dx dt. Dx dt was 2 minus 1 dy dt, and dy dt is what we're looking for. This is all over x, which is 4, minus y, which is 2. Equals 0. So we have 2 times 4 is 8 times 2. So that's 16 in that numerator, plus dy dt. That's all in parentheses, times 4 minus 2, which is 2. Minus 4 squared is 16. 16 minus 2 gives us 14. All times 2 minus dy dt. All over 4 minus 2, which is 2, equals 0. So I can distribute this 2 inside the parentheses. And we can distribute, let's distribute the negative 14.
Professor?
Yeah.
Did we square the bottom?
Nope, we did not. Thank you. So 4 minus 2 quantity squared, which should have given us 4. So 16 times 2 distributing in the numerator, we got 32 plus 2 dy dt minus 14 times 2, so 28. minus 14 times negative dy dt. So plus 14 dy dt. All over 4. Well, if we clear our fraction and we multiply both sides of our equation by 4, that's going to go away. And we'll be just left with a numerator, which would give us, and let's combine like terms as we're writing out the numerator. So I have a 32 minus a 28. So that's going to give me a positive 4. And I have a 2 dy dt plus a 14 dy dt. So that's a plus 16 dy dt. This is equal to 0. Let's get dy dt by itself. We would subtract 4 on both sides. So you have 16 dy dt equals negative 4, and then divide both sides by 16. So we have that dy dt is equal to, well, we can reduce negative 4 over 16. So that's negative 1/4. So the next example, same idea. This time we just have to apply the product rule when we're taking the derivative of both sides. So looking at this, we have y times natural log of x plus x times e raised to the y power is equal to 1. We're given dx dt is 5. We're given that x is equal to 1 when y is 0, and we want to find dy dt. So notice that when we take the derivative of this first piece, we're going to need to use the product rule. So derivative of y, so that's 1 dy dt times natural log plus y times the derivative of the second. So the derivative of natural log of x, so it's 1 over what you're taking the natural log of, which is x, times the derivative of what you're taking the natural log of, which is 1, dx dt. So that was just the derivative of this first piece. Then we have plus, and again, when we take the derivative of the second piece over here, grouping, we're going to have to use that product rule. So the derivative of x, which is 1 dx dt, times e to the y plus x times the derivative of e to the y, which is e to the y dy dt, equals derivative of 1 is 0. So we want to find dy dt. So I'm going to just underline every grouping that has a dy dt in there. So here's one piece, and here's one piece. Anything that doesn't have a dy dt, we want to get to the other side. And as I'm keeping these two over here, I'm going to factor out a dy dt from both of those. So if I pull out a dy dt, I don't know why my pen's not working. Sometimes if I just reset the battery. So we want to pull out that dy dt. So pulling that out, I'm left with a natural log of x. Pulling out the dy dt here, I'm left with the x, and it's positive, so plus x ey in parentheses equals, and I'm moving these pieces over to the other side, so I have to subtract them off. So minus y over x dx dt. This is just multiplication here. I just multiplied those together. Minus, I'm going to rewrite it as e to the y dx dt. This doesn't look too much like a t. So dy dt, we can divide both sides by that parentheses, is equal to negative y over x dx dt minus e to the y dx dt all over the natural log of x plus x e to the y. So we're just going to go in here, wherever we see a y, we're going to plug in 0. Wherever we see an x, we are going to plug in 1. And wherever we see dx dt, we're going to plug in a 5. So a negative y, which is 0, over x, which is 1, dx dt, minus e to the 0 times dx dt, which is 5, all over the natural log of 1 plus 1 e to the 0. Did x is 1. And dx dt was 5. Okay, so let's simplify that down. That 0 over 1, that's 0. So that negative doesn't even really matter. And 0 times 5 is 0. So we're getting our dy dt is equal to 0 minus e to the 0. Anything, a number raised to the 0 other than 0 is 1. So e to the 0 is 1 times this 5. So we have a negative 5 in our numerator, all over natural log of 1 is 0. E to what power gives us 1? Well, e to the 0 gives us 1. So that's 0 plus 1 times e to the 0, which is 1. So we have 1 in the denominator. And so we just found that dy dt is equal to 5. The rate of change of y with respect to t of this function or equation, given these values, gives us negative 5.